Recording. So I think we can start. 3 is good. So before we start, does anyone have a question? By now we've done a few things. You most probably should have questions. And here is the chance for you to ask your questions. Does anyone have a question? If you have a question, you can unmute yourself and speak up. Okay, if you don't have a question, we will start. And by the way, this is chapter 4, and it seems we are already going beyond our weekly allocation. So we won't do so much in this today because normally we shouldn't actually start this chapter yet. Okay, let's continue. So here we will discuss expressions. C, as the programming language we are studying, emphasizes expressions rather than statements. Expressions are built from variables, constants, and operators. And C has a rich number of operators. We have arithmetic operators, plus, minus. You remember we did the remainder, also called modulus. We have multiply. We have divide. We have a number of operators here. Also, we have relational operators. We have relationship between two things: greater, less, equal to, greater or equal to, less than or equal to, not equal to. So we have a number of these operators. And then we have logical operators. I guess you must have done something close to the in your mathematics, probably discrete mathematics, where you talk about logic, x and y, x or y, not x and y. So these are the logical operators. We have the and, or, and the not. And this is what the and looks like. This is logical and. This is logical or. This is or. Okay, this is bitwise or. This is logical or. And this is not. So we have a number of them. We have assignment operators. This is assignment. X is equal to y. This is assignment. But at the same time, we have compound assignments. We can have plus equal x or minus equal x. So as we continue, you get to know what this means. We have increment and decrement operators. If you want to say x is equal to x plus 1, that means you are increasing x. You are saying take the value of x, add 1 to it, and replace x with the new value. And this is the same thing as x plus plus. So adding plus plus to a variable helps us to increase the variable. But at the same time, it could be x minus minus. Here we are decreasing the variable. On the other hand, we can have pre-increment. This is called post-increment. We will discuss this later. This is called post-increment because the operators are at the right-hand side of the variable. On the other hand, we can actually have minus minus x. This is called pre-increment. This is pre-increment. So we have a number of operators in C that we will discuss very soon and we'll enjoy their behaviors. All right. So we go to arithmetic operators. Okay, we have five arithmetic operators. Okay, I think we already discussed all of these. Okay, we mentioned all five, so it makes our journey easier. So this addition, this subtraction, multiplication, division, and then the remainder. In many other programming languages, including mathematics, this is called the modulus operator. Modulus. It's called modulus operator. Uh, just a minute, please. All right. Back. So we said an operator is binary if it has two operands. I remember we discussed this last time. I showed you examples. So if we have A plus B, this operator plus is binary. Why? Because it requires two operands. It requires two operands. It's the same for almost all arithmetic operators except the negation. So minus can be 2. Minus can be minus, and minus is a binary operator. But minus can also be called negation. So we can say we want to negate. And if it is negate, it is a unary operator. So for minus, this is minus A minus B. This is binary. It has two operands. But there are times we can say minus B, and this is unary. Okay, so there are also two unary arithmetic operators. We have the unary plus. Okay, the unary plus it's meaningless. If I say B, it is the same thing as plus B. We know if we don't define it to be negative, it is plus. So it doesn't essentially make sense to have um, unary plus. But okay, let's accept that we have unary plus. So here is where there's a lot of difference, the unary minus. So this is the main unary operator in the C programming language. The unary operators require just one operand, like plus one, and also like minus one. But like I said, the unary plus operator does nothing. It is used primarily to just emphasize that a numeric constant is positive. It does nothing because even without the plus operator, if you all numeric values are assumed to be positive if you don't explicitly announce that they are negative. So it's useless. All right. The value of I mod j is the remainder when I is divided by j. Okay. So if you say 10 mod 3, it has a value of 1. Why? Because if we divide 10 by 3, we will have a remainder of 1. So what can we divide? We can divide 9. 9 by 3 is fine. So the remainder would be 1. 12 mod 4 is 0. Why? Because 12 can be divided by 4. Binary arithmetic operators, with the exception of percentage, binary arithmetic operators, with the exception of the remainder operator, allow either integers or floating point operands with mixing allowed. Okay, what this means is that integer or floating points are allowed. When int and float operands are mixed, the result has type float. Okay, so let's start with this first. What arithmetic operators do we have? Plus, minus, divide, multiply. Okay, on the other hand, we have the remainder operator. So the remainder operator is a special case. We come to it now. So what we are trying to say is that all these four operators allow us to mix types. So you can have integer 2 plus 4.4. So you can mix integer and float, integer plus float. Using the plus operator, you can do that. Using the minus operator, you can do that. Using the divide operator, you can do that. And using the multiplication operator, you can do that. This is just the idea. So mixing is allowed. You can actually have 2 plus 2, or you can have 2.5 plus 2.5, or you can have 2 plus 2.5. You can have any kind of mix with these four operators. But with this guy, you cannot have floating point. The only operand to the remainder operator is integer. All right, when integer and float operands are mixed, the result has type float. All right, so in this situation, when we had 2 with 4 plus 4, the result is going to be 6.4. The result is going to be 6.4. This is a very important concept in programming. It is called widening. So 2 is an integer. Integers are small. Integers use 4 bytes of memory. This is floating point. Floating points are larger. Why? Because it already has an integer part, which is taking 4 bytes. And also it has another floating point part, which takes another 4 bytes. So floating points generally are larger than integers. So they are 8 bytes. So when you want to add them together, integer plus floating point, we will need a memory location that can accommodate something that is large. So we use floating point for the result. So the result is going to be 2 plus 4.4. That would be 6.4. And that would be stored in, by the way, let me write bytes so that you are not confused about what this 4 means. So these are bytes, not numeric 4, like 4. All right. So because of that, we would need a floating point memory location for the addition of integer plus float. When divide an operator, the divide on the divide and modulus operator or remainder operator are very sensitive, and we need to take special care when we use them. When both operands are integers, divide truncates the result. So the value of 1 divided by 2 is 0, not 0.5. Okay. When both of the operands are integers, then the result also is forced to become an integer. So what is the result of 1 divided by 2? The answer is 0.5. But in C, the answer is not 0.5 because C does not help you to change the type. You are dividing two integers, so the answer must be integer. So the answer is 0.5, but we need the integer part of 0.5. So it cuts away the integer part and gives this to you as 0. The modulus operator requires integer operands. So you cannot have 4.5 modulus 3. It won't work. The remainder operator, it requires only integer. If either operand is not an integer, your program won't actually compile in the first place. So your program will refuse to compile. Also, if you try to divide by 0, if you use 0 as the right-hand side operand, you have 9 divided by 0. It would make C behave in an uncertain way. Or you have 9 modulus 0. It would make C to behave in an undefined way. The behavior when divide and remainder are used with negative operands is implementation defined in C89. All right, so you can determine how it behaves when you place negative operands. So if you have 5 divided by -2, it depends on how you have defined the usage in your programming environment. But in C99, the result of a division is always truncated towards 0. And the value of I mod j must have the same sign as I. So in C99, I mean, this is a newer version of C. This is a newer version of C, the C99. The value of I mod j has the same sign as I. The value of I mod j. So if I is minus and j is plus, the answer of this operation would be a negative value. If I were to be plus and j was negative, then the answer would be a positive answer. So does I plus j times k mean add I? Okay. Next thing we go to is operator precedence. Operator precedence. I think it's better we mention this before I start talking. operator precedence. Um, what do we mean by operator precedence? In expressions, we can have all sort of operators. Since we have 5 arithmetic operators, we can have their mix in whatsoever order and in whatsoever times. So we can have x plus y minus v divided by k. We can have them mixed up like that. So the question is, how do we solve the expression when we have a mix of them? Now, here we have I plus j times k. If we say we go from left to right, then we do I plus j first and we multiply the result by k. But somebody else who doesn't care about our rule may say, okay, let's multiply j with k and then add to I. The point is that the answers will be different. And because we cannot afford that answers be different in mathematics and in programming at the same time, we need to establish rules. And these rules help us to make sure that everyone who solves the same expression using the same rules, we get the same answer. And this is what is important in programming. We must have consistency. So that is where we have precedence. Which operator is higher priority than the other operator? So one solution to this problem is to first add parentheses. And so we say I plus j times k. This solves the problem completely because if we put parentheses, then we know that, okay, we solve the parentheses first, and then the result, we use it with the next operand and operator. Or we solve this parenthesis first, and the result, we bring it here for the next operand and operator. But if there are no parentheses, how do we determine? If there are no parentheses, how do we determine what to do? If just like this is what we have. And we do that using, as I said, operator precedence. If the parentheses are omitted, C uses operator precedence rule to determine how to solve an expression, what the meaning of an expression is. The arithmetic operators have the following relative precedence. The highest precedence is the unary operator. So in any arithmetic expression, the first thing you solve would be the unary operators. And here is what I mean. Let's just open a little text window. So if I have 3 plus 2 plus minus 5 times 2 times 3 times 7 divided by 2 minus 4. All right, let's make it a bit big. Yes, this looks nice. Okay, let's put some space. Okay, I think this is enough. Okay, let's put more. Maybe for this minus I don't put. Now let's reduce the size a bit. Yes, everyone fits well. All right. So what we are saying is, if you assume that we have this kind of expression, how do we solve this expression? The first thing we will do is we deal with the unary operators. Where are the unary operators? Here is a unary operator, minus 5. So we have to make sure that we deal with minus 5 first. All right. So minus 5 converts this expression to 2 minus 5. And after that, we deal with the multiply, divide, and remainder. Okay, here we don't have remainder, so we deal with the multiply and the divide. So we deal with the multiplies and the divide. Okay, automatically we already see that we have a problem because we have many multiplies and divide. Since they are all equal, there's a problem. Okay, let's keep this problem. We will solve this problem very soon because there is another rule that helps us in solving this problem. And finally, we move to the lowest, which is plus and minus, the binary plus and the binary minus. So finally, we'll come to this guy and we come to these guys. Those will be the last. So here's an example. If we have I plus j times k, Since we know that the unaries are higher, there is no unary operator. Then we move to multiply and divide and the remainder. Yes, we have multiply here. So this becomes our first expression to solve. And then we can add to high. And that's what we have here. Here also, we have the same thing, but since we have unary operator, we deal with the unary operator first. And when we get the answer of the unary operator, we can then deal with the entire expression after we solve the unary operator. Okay, here is the final one. We have a unary operator, and then we have the division, and then we have complete addition. All right, associativity. Now, as I said that there are times that we fall into some complex situations like this. All these four operators are on the same level of precedence. So what do we do? Which one do we solve first? Do we divide 4 by 2 or we multiply 4 by 3, or actually it is 5 we multiply by 2? Which one do we do? Or probably it is 2 we multiply by 3. Which one do we do? We use the associativity rule to determine which one we will do. All right. So associativity comes into play when expression contains two or more operators with equal precedence. So here we have more than two. In fact, we have one, two, three, four. So we have four operators with the same precedence in our example. An operator is said to be left associative if it groups from left to right. So in this situation, when we have more than one, we have to think about associativity. And associativity tells us that with operators of the same level of precedence, we can solve the operation either from left to right or from right to left. This is the meaning of associativity. So we can solve either from left to right or from right to left. Let me show to you what I mean. We can solve from left to right or from right to left. This is right to left, while this is, um, let's make some space, left to right. Yes. Now, the associativity of each operator will tell us what to do. For some operators, we go from left to right, but for some other operators, we go from right to left. Okay, let's continue. An operator is said to be left associative if it groups from left to right. So if it goes from left to right, we say it is left associative. If it groups from right to left, it is right associative. The binary arithmetic operators multiply, divide, remainder, plus, minus are all left associative. They are all left associative. Now, because they are left associative, it tells us that we solve from left to right, any operation that includes multiply. So this is multiply. Since we have many multiplies and divides and everything, we start from left to right because it is left associative. We start from left to right. So this is the first thing we solve. After ensuring that this is minus, then what do we do? We multiply 5 by 2. What does that become? 10. And then we go with minus 10, since this minus sign, times 3, and that becomes minus 30. And again, we go minus 30 times 4, and that becomes minus 120. And we go on more time, minus 120 divided by 2, and that is minus 60. So we have, let me move to the next line. So let's say we just gradually make progress. Let's copy this, bring it here, um, come to the middle. Since the first thing we do is we solve the negation, then we have this, and then we move to the next thing. Okay. Now we have this, and this is now minus 60. Great. So we have made use of the left to right associativity for multiply and divide. And then we say it's the same thing for addition and subtraction. So we start from left to right for addition and subtraction. What else do? We start from here. 3 plus 2 is what? Is 5. Minus 60. That is minus 55. Minus 4 is minus 59. So we stop at minus 59 as the result of our expression. So that means minus j, I minus j minus k is the same thing as you start from the left. I minus j, and then the result of that, you subtract k from it. I times j divided by k is still the same thing. You start from the left because they are arithmetic operators. And then you deal with k. All right. That's just it. Does anybody have any question? Any question? None. That's okay. So we move ahead. An operator, on the other hand, is right associative. An operator is right associative if it groups from right to left. If it groups from right to left, we already discussed that. So the unary arithmetic operators plus and minus are both right associative. So the unary operators are right associative, which means if you have more than one negation, you have to start from the right. So if we had, let's say we had minus 4, we would solve this first, and then we solve this. All right. Assignment operators. We have simple assignment and compound assignment. We have simple and compound assignment. Okay, I think we discussed this right from the beginning. I think I mentioned this. Yes, these are assignment operators. This is simple assignment, and this is compound assignment. Actually, this is not exhaustive. We can have 2 more at least. I mean, multiply equal. We can have divide equal. We can have a number of things. So let's let's move to simple assignment. This is simply used for storing a value into a variable. So if you say b is equal to 7, this is simple assignment, because you just say from now on we have stored 7 in b and the location of 7 is b. On the other hand, we can have compound assignment. This is used for updating a value that is already stored in a variable. Used for updating a value that is already stored in a variable. So here is what it means. If we say b is equal to 3, on the next line we can say b plus equal 4. And at this point, b becomes 4 plus 3, 7. So b now has value 7 in it. Any question? Do you have any question? All right. So let's do a new thing. All right. So let's say int a is equal to 3. Then we can print f percentage D slash N A. A now is percentage D. All right. So we can print the current value of A, and then we can say A after update is this. So let's now say A plus equal 4. So we get a new value for A. So what do we expect? Here, it would print the current value of A. A is 3. Here, it takes the value of A, it adds it to 4, and then it gets 7, and so it assigns 7 back to A. So the new value of A becomes 7. And so here, it has to print A after update is 7. Okay, we don't need to define anything here. All right, let's run our code again. Right, what's going on? Oh, yes, I think our code works. Yes. So just observe what we explained. We explained that A is now 3. It's simple. This is what we assigned into A. We assign 3 and then we print it as an integer. We say, okay, A now is percentage D. It takes the value here, puts it in the placeholder, and so it displays 3. Next, we do A plus equal 4. And so we ask it that it should display the new value of A, but since the new value of A is A plus 4, so we have 7, and that's why we have 7 here. On the other hand, we can change it. We can change this to minus, and if we change this to minus, it changes the value of A to 3 minus 4, which becomes minus 1. And so we have our new value as minus 1. That's minus 1. Okay, we can make it multiply. We can make it multiply. It's about the same thing. It changes to 12. And if we put divide, we'll have a problem. We'll have a problem because 4 divided by 3, 3 divided by 4 is going to be 0 point something. And so our answer is expected to be the integer of 0 point something, which is 0. All right. Okay, maybe we can increase this. Maybe we can increase this to 9 and see what will happen. So A divided by B is equal to 2. So divide 9 by 4, it goes twice. All right, let's do this. And the answer is 1. 9 mod 4. So when we divide 9 by 4, we can't. We can only divide 8 by 4. So we can subtract 8 from 9, and so the remainder is 1. All right. So this is what we call compound assignment. By the way we have done everything, this is compound assignment, this is simple assignment. I guess it's pretty understandable for you. Any question, please? Do you have questions? Okay. All right, so for simple assignment, we can have it in whatever way. We can just say j is equal to 5. We can say j is equal to I, so j becomes the current value in I, which is 5. So it still doesn't matter the arrangement of things. k is equal to 10 times I plus j. Okay, so at this side of the expression, we follow the rule of associativity and the rule of precedence. Since we said arithmetic expressions, we have this to be of the same level. What then do? We follow precedence, which says we go from left to right. So we multiply 10 by I, which is 50, 10 times j, which is 50 by 5, that's 250. So k becomes, okay, plus, that's 50 plus 5, that is now 55. That's 55. So this is simple assignment. All right. Observe, if V and E don't have the same type, then the value of E is converted to the value of V as the assignment takes place. So here we are assuming that this is what we have, V is equal to E. Okay, so let's say V is equal to E. So what is on the right hand side is E. What is on the left hand side is V. If V and E don't have the same type, then the value of E is converted to the type of V. So what is V? If V is integer and E is float, then the value of E is converted to the type of V. So if we have I is equal to 72.99, this is float. This is integer. When we store a float inside of an integer, the floating point cannot create extra storage space for the integer, so we can't store it as a floating point. We have to remove the floating part of it and throw it away. So only 72 gets stored in the integer variable. On the other hand, if we try to store an integer inside of a float, what happens? Oh, float is large, it can take the entire integer. So there's no problem. We just accept the integer into the float, and then we change the integer from being an integer to a float. We put 0 at the back. And that is what we have. So we store zeros at the back, but we must change the type. In many programming languages, assignment is a statement. However, in C, assignment is an operator. Assignment is an operator. So this is important. In many languages, here is assignment. X is equal to 4. And because it's just a statement, you cannot consider it as a complex expression. But in C, it can be used to build a real complex expression. So you can have X is equal to Y is equal to B is equal to Z is equal to V is equal to 7. You can have this in C. You can have this in C. Why? Because it's just assignment is seen as an operator, it's seen like plus. So you can also, since you can have X plus Y plus B plus Z plus V is equal to 7. Since you can have this, plus 7. Since you can have this, then you can have it like this also in C, because the assignment symbol is an operator. So we call it the assignment operator. All right. The value of an assignment V is equal to E is the value of V after the assignment. Okay. So the value of this expression is the value of V, whatever is in V. So if we have A is equal to 9, the value of this expression is 9, because after this expression, A takes the value of 9. So the value of this expression is 9. So the value of I is equal to 72.99 is the value of I after the expression. This is really important that you understand. So on the right hand side, we have a float. On the left hand side, we have an integer. So the value of an expression is the value of the variable to which you are assigning to. Because if the type of the variable you are assigning to is different from the type of the constant you are assigning to it, the entire expression would have a different meaning. And so we say the value of this expression is what I want. What I want. I is an integer, so I want 72. And since I want 72, we forget about 72.99. The value of this expression is 72. And this really plays an important role in this kind of expression because we will have a change of type or a propagation of type change in the expression. So this is an example, a chained assignment. Since the assignment symbol is an operator, so we can chain it together. So what goes on? The assignment operator is right associative, clearly. So we have to assign a value to k before we can assign the value to j. This is the meaning. It is right associative. We must assign the value to k before we assign the value to j. So, okay, maybe I change the color also. So here is the next thing. So this is what happens. So what is the type of k? If okay, it's 0, so it's a bit easier to manage. K um, has no defined type. Are we seeing the type of K? Is it written anywhere ahead? No, it's not written anywhere. Okay, so this is chaining. The assignment operator is right associative. So this assignment is equal to this. Okay, it's the same thing as what we wrote, except that we had an extra parenthesis. Watch out for unexpected results in chained assignments as a result of type conversion. Now, since we said that the effect or the value of this expression is not essentially 33.3, the value of this expression is the type of I. And since I is integer, the value of this expression is 33, not 33.3. That means when we are assigning to F, we are not assigning 33.3. We are assigning the value of I. We are assigning 33 to F. So this expression becomes F is equal to 33 because F is equal to high. And what is in high is what we see. Now, observe that F is a floating point. So F would not save 33 as an integer. It's going to save it as 33.0. Now, observe what has happened. We have lost the precision of 0.3 as we used chaining assignment. So this is the disadvantage of chaining assignment. When you chain assignment operators together, you need to also keep in mind that the assignment operator is right associative. So it groups from right to left, which means it solves the expression from right to left. It assigns value as it moves from right to left. And as it assigns value as it moves from right to left, it assigns the effective value of that expression on the right to the variable on the left, which may affect the final outcome of the expression, just like we have seen here. So we see that F is equal to high is equal to 33 does not end up saving 33.3 inside of F. It saves only 33.0 because the value had to go through I, and I had truncated the 0.3 off. So it's important to keep this in your mind. Embedded assignments. Let me skip forward to see what we have. L values, compound assignment, increment and decrement operation. All right. Since we are ahead of the plan for the class, I think we can stop here. So let's stop here. Let's stop here. We'll resume from here some other time. Do you have any question? Okay, if you don't have any question, we'll be stopping here. I want you to write present in the chat so that I can be certain that you are not sleeping. Write present in the chat before I close the class session.